class, welcome to Advantage. I'm Sean Flaherty, your instructor for Physics 1 Mechanics. In the previous video, we talked about the organization of a typical mechanics course along with identifying some essential skills that will help you to be successful. In this video, the focus is on an example which really highlights some of the subtleties here. In this first example, without getting into all of the details of some of these terms, we're going to look at motion, and we'll start with a very general description. Is suppose an object moved 5 meters. That's all we know. So what does that mean, really? Like, what's all the information we can get from there? Maybe the object was here, and then, shoot, if all I said was it moved 5 meters, it could be here, if that's 5 meters. It could be up here, or anywhere. I've just given a radius, essentially. I have no idea where that thing is. So I'm not talking about position or location. I don't have enough information to do that. I just know how far it went. So I've been given a distance. I have some initial spot and some final spot. And all I really know is that's 5 meters. Now this drawing is one of infinitely many I could have done. Again, 5 meters would be this entire radius. But this is one of the possible ones. Let's suppose, there I have 5 meters. This object went 5 meters. The distance traveled would be 5 meters. Now there's another word that sounds a little bit like distance that's often related to distance, but they're not the same thing, and that's called displacement. And if you were asked to solve for what is the displacement, there's more information that's necessary. You can't just say the 5 meters because displacement is subtly different than distance. Yes, it's still 5 meters, but displacement is something called a vector quantity. And so a vector quantity has a magnitude, in this case 5 meters, but it also has a direction, like that away. It went from down here, the initial position, diagonally up to that final position. Typically with displacement, we would describe that direction with an angle measure. So in this case, 5 meters at, I'm just going to pick an approximate angle. Well, that looks like about 53 degrees to me. You'll see why that comes into play later, maybe. All right, so displacement in this case would be 5 meters at 53 degrees. And if you didn't say the at 53 degrees, you're not answering a displacement question. You're only answering a distance question. There's a subtle difference. But wait, there's more. If the question was, where is the object located after it has traveled 5 meters, we're asking about a position. And you're not allowed to just say there, like that's not a good enough description. So we'd have to find a way to describe position effectively and clearly. And in this case, for my made up example, if you travel 5 meters at about 53 degrees, it's the same as going over 3 meters and going up 4 meters. There's some Pythagorean theorem or something you can do there, right? 3 squared plus 4 squared is going to get you that. But how would we describe that position? There's actually some other information that's needed for position. In order to describe a position, you need a coordinate system to be defined. That needs an origin of measurement and definition of direction. So if I said over here, is my origin of measurement. And I maybe started, let's see, that's about 3. That looks like 3 in the x-axis, 0 in the y-axis. I'll draw some axes. Well, that's my positive y, and that's my positive x. Now this position could be described as an ordered pair. Let's see, what would it be? 3 over and 3 more over, so that would be 6 for an x value and 4 for a y value. So the position is at 6, 4, given that particular coordinate system. Another way to do that is to write the position as a vector is 6 I hat plus 4 j hat. Now that notation might be completely new to you, and that's okay. We're going to go over it in greater detail in a later video. So starting with something simple, an object just moving 5 meters, we have some differences. We could talk about distance, we could talk about displacement, we talk about position. Depending on what the question might be, you have a variety of different answers possible. In this next example, let's suppose we knew an object moved 3 meters to the right and then it moved 4 meters up. I haven't really changed a whole lot here except saying it did this motion first, followed by this other motion. Well, what is the distance traveled? In this example, the distance traveled is 3 meters, then 4 meters, so the distance traveled in this example is 7 meters. The displacement, in this case, is still starting from here, ending at that location. In this case, the displacement is unchanged. That's still 5 meters at about 53 degrees. And the position is still at 6, 4 as an ordered pair, or 6 I hat plus 4 j hat. So depending on some subtle differences in the language of the question, of the given information, what you're asked to solve for, there can be some changes here. Often the examples given don't feature the differences, and you might be misled that distance, displacement, and position might be different words for the same thing. That's not okay. Let's play what if real quick. Let's suppose we just walked directly to the right 5 meters. We didn't go up or down at all. Well, in that case, the distance traveled would be 5 meters. The displacement would also be 5 meters. And if I would have put the origin of measurement here at the initial position, the final position would also be 5 meters. So be very mindful as you solve the problems and look for some of these subtleties. And I do encourage you to play what if on occasion. What if the question was asked a little bit differently? How might I have answered it then? Thanks for coming. I hope that you appreciated it or found some value in it. And in our next video, we will be talking in greater detail about kinematics, the study of motion. Thank you.